Namaste. This is JV and Dr. Vishal Saxena, Professor in Mathematics in Department of DST under the Faculty of Science and under the Faculty of Education and Methodology. So today I'm going to take a lecture on the topic basic definitions of set, and this module, this lecture is from the course of Mathematics Second and under the program of DET, Computer Science, second semester. So the today's module is just for the set theory, and it is just related with computer science, DET computer science, and the just we are discussing on this module. So first we have to understand what is a set, and then we have to see the various definitions, basic definitions of set theory. So a set means it is a collection of objects and a collection of well-defined objects that is called a set. And suppose we are having some numbers and we are having some objects. So that is a set here. Suppose just for example, if I want to give here suppose a set means A, and that is the set of the numbers, natural numbers from 1 to 10. So this set is consisting here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is the set, and just a set of natural numbers. So for this more here about the various definitions, I'm going to take some slides, and so now we can see this one. Just set is coming there. So look at this one. Set means here the set means the set can be defined as a well-defined collection of definite objects. Means it is a set, and that is just consisting the well. It is a well-defined collection of the definite objects. So just means a set can also be considered as a grouping together of single objects into a whole. The objects should be distinct from each other, and they should be distinguished from all those objects that do not form the set under consideration. So the objects should be distinct from each other in a set, just which is a collection of objects, and the condition means just we can give here that the object should be different, distinct from each other, and they should be distinguished from all those objects that do not from the under consideration. So generally, a set is denoted by a capital symbol, and just master of elements of a set are separated by an enclosed this kind of curly bracket. So it is the just notation to write a set there, and it is written by a set is denoted by a capital symbol, and a master or and the master or the elements of a set are be separated by the enclosed in this curly bracket. For example, just we can give set of natural numbers. So the set of natural number means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as already we know that just the natural numbers in mathematics, the natural numbers are from started from 1, and it goes on here like 1, 2, 3, 4, 5, 6. So this is the set. This is the collection of the natural numbers, and this is the set just consisting of all the natural numbers. Next example is a set of prime numbers. So set of prime numbers just we can give there, like the first number as already we know that 2. So 2, 3, 5, 7, then 11, 13, 17, 19. All these are the examples of the prime numbers. So in this way, just we can give here, this is the set of the prime numbers, and just we can see here, this is the set for the prime numbers. Again, it is the example of the set here. Now we have to just take the different definitions of the set theory. So just we are going to discuss the different kind of sets. Now here, the first one is the finite set. The finite set means it is a set that consists of a finite number of objects or in which number of elements in the set is finite. So a finite set means just it is a set that consists of the finite number of objects or in which number of elements in that set is finite. So now we can see this one. For example, set A is given by 3, 5, 7, 9, 11, 13, 15. So this is the set and we can see this one. It is a set just consisting the finite number of elements. In a similar way, the set B is again given there. Some elements are there like 4, 8, 16, 32, 64. So again, this is the example of the just a finite set. And here just A and B contains finite number of elements that now we can observe that set A is consisting here just 3 and 5 and 7 elements. And while the set B is consisting here 5 elements. So it means the two sets are the finite sets. Now second is here we are going to discuss the infinite set. The infinite set means if the number of elements in a set is not finite, means the number when the number of elements in a set is not finite, means when the number of elements in that set is infinite. So the set is called an infinite set. So thus the set of all natural numbers is given by n is equal to 1, 2, 3, 4, and so on is an infinite set. So this is the set of natural numbers and just it is a set just consisting infinite number of elements and that's why it is called a just infinite set. And so many examples we can give there. One more example is given that for the set of rational numbers, so it is A is equal to X, such that X just belongs to E and X belongs to Q. Q means the set of rational numbers and X is greater than to 0 and less than to 1. So because there are infinite number of elements between 0 and 1, so this is the set of rational numbers between 0 and 1 and infinite rational numbers can be there. So it is a set of infinite numbers and that's why it is an infinite set. Singleton set, next one is singleton set and singleton set means this is a set which is just consisting only one element. So it is a set consisting of only one element and this is called the singleton set. So for example, just we can give here the set consisting only 4. Another example, the set consisting only one element 1 and the set consisting of element A. So all these are the examples of these are the examples of singleton set because just we can observe that only one element is there and that's why it is called a singleton set. Null set or empty set, this is the fourth definition, null set or the empty set. So null set means that is also known as empty set and this is the set in which here just there is no element means the whole set is empty and that's why it is called the null set. So A means when A is equal to just the set and it does not contain any element then it is called a null set and it is also just given by 5. This is also called 5. 5 means it shows here the null set and cardinality of the set A. What is meaning of cardinality? Cardinality means how many elements are there in that set. So because there is no element, that's why its cardinality will be 0. There is two particular representation, either empty curly just braces or a special symbol phi. So phi just shows also a null set or we can give here that just one is a curly braces. That is also the another way to represent the null set. Next is the fifth point, that is equal sets. Equal set means this is the set the when the two sets A and B having the same elements, then the two sets A and B are called equal sets. This means that when the two sets A and B just are having same elements, means when the exactly the two sets are having the same elements as well as the equal numbers of elements in the two sets. Suppose the set A is consisting five elements, and suppose B the set is again consisting five elements, and all the elements are also same in the two sets. Then the such two sets are called the equal sets. Next one is the subset. Subset means this is the like we can say just we can understand here a country, any country which is a part of any just we can say, or when any state just that is a part of the country here, particular country. So country means that is consisting the whole state, so that's why just the country is called a superset, and the state for example just Rajasthan or Delhi, these are the states in the like India. So India is the superset, and the set like Rajasthan or Madhya Pradesh or other state is called a subset of that set here. So it means now we define its a proper definition. A subset A is said to be subset of B. Okay, so a subset A is said to be subset of B if every element which belong to A also belongs to B. So it means a set A. We should say instead of subset that is a set A is said to be subset of the set B if every element of set A is just of if every elements of which every element which belongs to A which is also belongs to B set. For example, like the set A, suppose 0, 1, 2, 3, and the set B is 0, 1, 2, 3, 4, 5. Then we can observe that the all the elements of set A are just the elements of set B. Means all the elements of set A are lying in the set B, and therefore the set B is called superset of A, while the set A, which is smaller than set B, is called the subset of just set B. Next definition is the proper set and the improper set. So proper set and improper set means a set A is said to be a proper subset of B if A is a subset of B and A is not equal to B. That means we can say when the set A is called a proper subset of set B if the set A is entirely lying inside the set B, then the set A is called the proper subset of the set B. So in this condition here, for the proper set, we are saying the A is the proper subset of set B. That means the set A cannot be equal to set B, and the whole set A just lying inside the set B. So that is called the proper set. For example, just we can explain that suppose a set of n is a set of natural numbers. So n is a set of natural numbers means n is consisting all the natural numbers right from 1, 2, 3, 4, and all the elements. This means that This means that the proper set, the A is called the proper subset of B. That means the set A is entirely lying inside the set B. So that is called a proper set. And improper set means set A is called an improper subset of B if and only if A is equal to B. So it means when the set A is equal to B, okay. So in that case, the set A is called the improper subset of B, and just this is a condition whenever A is equal to B, then the set A is called the improper subset of B. Next is the power set. Power set means it is a set of all the just possible subsets of a set. So means suppose here just A is a set and power set means the power set means for the set A is that set which is consisting all the subsets of the set A. So power set means it is a set of it is a set power set of a set is defined as a set of every possible subset. And if the set of A, if the cardinality of A is n, then the cardinality of set B is 2 raised to the power n. So this is the definition of power set. And at the last, we are going to discuss the universal set. Universal set means it is any set which is a superset of all the sets under consideration. So any set which is a superset of all the sets under consideration is called the universal set, and it is written by capital U or omega or S. For example, suppose A is the set 0, 1, 2, 3, and set is C is 1, 2, 3, 1, comma 2, comma 5, comma 6. Then set S consisting both A and C, and some other elements may also be there, and this set S is called the universal set. So just this is the definition of universal set, and in the today's lecture we have discussed about the various definitions of set theory, and we have discussed the various types of set. So with this here, I'm going to just complete my today's lecture. Thank you.